Hello, and welcome to Section 4.1, Maximum and Minimum Values of a Function. In this section, we're going to talk about two types of max and min values. There's the absolute type, which means you have a maximum or minimum value of a function of all the other function values possible, or local, which means that just in a neighborhood, a certain subinterval of the x-axis, you have points that are higher or lower than all the other ones near it in that interval. So the first type we're going to talk about are absolute max and mins. Another term for maximum or minimum is extremum. So that's kind of collective, means it could be either, and its plural is extrema, just like the plural of minimum is minima, and the plural of maximum is maxima. So let's first look at the definition of absolute or global extrema. So if c is a number in the domain of a function, then f of c is an absolute maximum of the function f on the domain D if the function value at c is greater than or equal to all the other function values for all x in D. And likewise, the absolute minimum, f of c is an absolute minimum if it is less than or equal to all the other function values for all the other x values in D. So graphically, an absolute maximum is the highest point on a graph, meaning the y value is the greatest, and an absolute minimum is the lowest. So here's an example with, I've added the points to it. So the domain is this closed interval minus 2.1 to 2.1. And this is a polynomial function that I've restricted to this domain. And you can see that this value of function value of 3.631 is an absolute maximum, and it occurs at x equals minus 1.644. The function minimum is minus 3.631, and that occurs at the x value 1.644. So that's a terminology point. When you're asked for the absolute or local max or min, that's asking for a y value, not the whole entire point. So not all functions have absolute extrema. For instance, it depends on the domain. It depends on the function itself. So for instance, f of x equals e to the minus x is pictured here. It has no extrema on its domain because its domain is all real numbers, first of all. We know that as x goes to negative infinity, this goes up to infinity, so there's no maximum value there. And as x goes to positive infinity, y goes to the horizontal asymptote at y equals 0, but it never reaches it. So that may be its limit as x goes to positive infinity, but it does not have an absolute minimum. The other type of extrema that we talk about are local extrema. So a local max or min is a y value that occurs at a turning point, a place where the graph changes direction. So here's a local minimum, here's a local maximum, because the graph is turning around and changing here. So if you think about it, the y values to the left of this maximum are smaller than the maximum value here, and the y values to the right of it are smaller, and we'll see more about that in a minute. So note also that a local maximum can be an absolute maximum as well, just like a local min can be an absolute minimum. So these points were the absolute max and mins that we saw on the previous slide, but they're also considered local. And here is why they're considered local as well, because there's a neighborhood. In other words, there's a piece of the graph on both sides of each of these points that the y value here is greater than all of the other y values for the absolute max, and the y values here are less than all the other ones around it. So that's a local extremum. So I talk a little bit more about these neighborhoods because that can be a little confusing. So if you look at, for instance, this local maximum occurring here at about 0.5. To the left of it, the function's defined and all those y values are less than it. And to the right of it, the function's defined there and all the y values are less than it. So this piece of graph is over this little interval on the x-axis, and that's called the neighborhood of this local maximum point. So there's values for the function to both the left and right of a local max or min. That's what makes it a local max or a local min. So going back to this definition, the local maximum value is greater than all the other x values on some interval containing C. So that's also called the neighborhood of C. So that's something to keep in mind because we're going to see that you can't have a local maximum at an endpoint because there's not a neighborhood both to the right and the left. So if we put point values to our graph, we see that we can see the actual values of the local max and min. So this local min, it's a local minimum of minus 1.4019, and it occurs at x equals minus 0.544, and the local max is 1.419, and it occurs at the x value 0.544. Notice in this function I have an absolute minimum that's also an absolute maximum here that's also a local maximum because it's the highest point on the graph, and it also is not at an endpoint. So it's local because it's not at an endpoint, and it's absolute because it's the highest point out of all the other points. Again, not all functions have local extrema, just like not all functions have absolute. So now let's change that function a little bit that we've been looking at. So before the domain was minus 2.1 to 2.1. And now I've changed it to minus 2.1 to 2.2. So now my endpoint is higher than all the other points in the graph. So this is an absolute maximum. I have a new absolute maximum. Before I extended this domain, this was the absolute maximum. But now that I have this one at the endpoint, I can't call that a local maximum. Because again, this is at the end of the domain here. So there aren't any x values to the right, any function values to the right of it to compare it to say that it's a local max. So an absolute extremum can occur at an endpoint of a closed interval, but not a local extremum.